So let's go ahead with the examples. Now we are going to look at the applicability of the sums and products of the roots of the quadratic equation. So we are starting with the first example. Example 1. If alpha and beta are the roots of the equation, x squared plus 10x plus 1 equals 0, find the values of part A, alpha, beta, part B, alpha plus beta, part C, alpha squared plus beta squared, part D, alpha squared beta plus alpha beta squared, part E, 1 over alpha plus 1 over beta. So let's look at the solution. I'll first read for you again to echo it back. If alpha and beta are the roots of the equation, x squared plus 10x plus 1 equals 0, find the values of part A, alpha beta, part B, alpha plus beta, part C, alpha squared plus beta squared, part D, alpha squared beta plus alpha beta squared, part E, 1 over alpha plus 1 over beta. So before we proceed with this, first look at that alpha and beta are the roots which are being used in this equation. And our quadratic equation is already given as x squared plus 10x plus 1 equals 0. Before you proceed, always first check your equation. Is your equation is x squared having a coefficient of 1? If it is not having a coefficient of 1, automatically first divide both sides by that number which is there, so that you can have a coefficient of 1. I'm begging and I'm requesting, don't go ahead to calculate a number when x squared is not having a coefficient of 1. The result will not be accurate, which will come out. So here you can see that it is already 1. So this is the sum, this is the product. So can we go ahead and look at our sum of roots? We are looking at sum of roots, which we are calling alpha plus beta. We said when it is a positive, it automatically becomes a negative. We also look at the product of roots. Our roots, remember, are alpha and beta. Products of roots, which we are calling alpha beta, which is automatically 1. So we are now starting with what was asked in the question. Part A was saying, find the value of alpha beta. Our alpha beta is already what? Alpha beta is the product, which is 1. Then there you have already qualified for the mark of it. We also go to part B. Part B is saying alpha plus beta. Alpha plus beta is just talking about the sum, which is already negative 10. So our alpha plus beta is negative 10. We go to part C. Part C is talking about alpha squared plus beta squared. So I've got alpha squared plus beta squared. We said with alpha squared plus beta squared, this one is an identity, which we have already proved. We have already proved and we are moving together. So alpha squared plus beta squared is the same as alpha plus beta, the whole of it squared, minus 2 alpha beta. Do we know alpha plus beta? Alpha plus beta is already a negative 10. So we are free to substitute it. We are going to say negative 10, the whole of it squared, minus 2 times, what is alpha beta? Is 1. Negative 10 squared, we are getting 100, minus 2 times 1, that is a 2. Automatically you are coming out with 98. You have already scored that mark for you. So let's go to part D. Part part that is containing alpha squared beta plus alpha beta squared. So what happens with this? With this, I normally advise you first look at what is common. What is common is, you can see there is alpha beta. Again, alpha beta. So what is common is alpha beta. Automatically first factor out the common factor. That is alpha beta. Then automatically will remain with one. Alpha is already outside and beta is out. What am I remaining with? I'm remaining with alpha plus. Then alpha is already out and one beta is out. That means I'm remaining with beta. So after factoring out that, we are having alpha beta into alpha plus beta. But do we know alpha beta? Alpha beta is already a 1. And our alpha plus beta is already -10. So we are free to substitute it. I will say this is 1 into -10. Automatically we are coming out with -10. That one is already the expression for that value which they have asked for it. Then we go to part E. Part E is saying 1 over alpha plus 1 out of beta. So what I'm going to do is this. You can see this one is in the form of fractions, the usual fraction which we have been doing. So what I encourage you is automatically 1. First get the LCM. Can we get the LCM? Our LCM is alpha beta. Because alpha and beta, the LCM is alpha beta. So we go on as usual. Alpha beta divided by alpha. What are you getting? I'm coming out with beta. Then beta times 1, I'm getting beta. Then plus alpha beta times divided by beta, we are getting alpha. Alpha times 1, we are getting alpha. So this one becomes alpha plus beta all over alpha beta. Do we know alpha plus beta? Alpha plus beta is already our -10. So this one becomes -10 divided by 1. So any number divided by 1 remains as in that number. So it becomes -10. That's how we normally calculate such kind of example. So as we are going for a short break, so we are going to return to the next example.